All right, hello. Today we're going to be talking about matter and change. And so as we go through this PowerPoint, there will be points when I will have some questions, some prompts that will be up on the board. And you might want to hit pause every once in a while so that you can answer those questions. And then I'll just keep zooming right through it, but you might want to hit pause, give yourself some time to think about it, and then move on to the next thing, okay? All right, so here we go, matter and change. So this is chapter 1, and what we're going to be talking about here today for our objectives, we obviously want to look at what chemistry is. We want to figure out the difference between physical and chemical properties, to distinguish between intensive and extensive physical properties, to look at the physical and chemical changes and look at the characteristics of a chemical change, to look at 3 common states of matter, and to explain the energy role in physical and chemical changes. Okay, so if we are going to come out of here with some success, then you're going to be able to tell me what chemistry is, right? You're going to be able to say, hey, that's the study of matter, processes, and energy changes, and you'll know what that means instead of just having a verbalization. You're going to look at any particular property of matter, and you'll be able to tell me, oh, yeah, that's a chemical property of matter, or that's a physical property. And then you're going to be able to tell me what intensive and extensive properties are. And then if I give you a change description, a description of some sort of change, you're going to be able to tell me if it's a physical or chemical change. And then, of course, you're going to be able to identify and explain the characteristics of those 3 common states of matter. In fact, we're going to talk about 4 states of matter. 3 will be primary. 4th one is super important as well. All right, so our first concept here, as we will advance the slide, theoretically. There we go. All right, chemistry is, you should be able to define that, right? And if you look in the book, it basically says the study of matter, its processes, and energy changes. So chemistry is the study of everything, right? You're going to have all sorts of things with regard to chemistry. In fact, there's nothing that you typically think of, and I'm not going to say nothing. There are a lot of things that you are going to think of that are going to be chemistry or chemicals, and there are very few things that you can think of that will not be. I bet you can think of a couple different instances that would not be chemicals, but most things that we think of in this universe are chemicals. So chemistry is everywhere, and it's about everything. All right, so we're going to jump into the second little section. We basically kind of combine sections 1.1 and 1.2 together here. And so we're going to kind of jump into 1.2 a little bit as we continue on here. All right, so this is a little bit of a review. Notice that this is not in your chapter, so you need to make sure you guys have written this down if you don't know it already. So what is matter? Well, one of the things we can say, one of the properties of matter is that it has volume, right? It's going to take up space. And so the amount of 3-dimensional space an object occupies is going to be considered its volume. You should memorize, okay, that there are 1 cubic centimeters and 1 milliliter, all right? This is going to be true. We basically have defined a milliliter based upon a centimeter by a centimeter by a centimeter, so this is going to be true all the time. Then we've got a couple other things we want to talk about, and one of them is mass, the other is matter. So mass is not quite the same thing as matter. Okay, mass is the amount of matter in something, and matter is anything that takes up space and has mass. And so you'll notice here matter kind of encompasses these 2 concepts, mass and volume, together. But mass is something, it's basically a way that we measure matter. If you think about the difference between mass and weight, mass is going to be the same no matter where you are in a system, whereas weight is going to change depending upon like the planet you're on or whatever, you know, even the elevation that you are in a mountain. So mass and matter are a little bit different from each other. Obviously, mass and weight are different from each other. And so just kind of make sure you have those distinctions. And I actually see a lot of students that actually get confused about volume and mass as well. So just remember, volume is space that takes up it. So mass has volume, matter has volume, but they're not the same thing, okay? All right, as we go on to our next one, this one you're going to see in something that I want you to, again, maybe pause as you're going through this. We want to identify one example of something that is matter and something that is not matter. Okay, so if you need to pause, go ahead. But you could basically name anything in the room is going to be matter, right? So a desk is going to be matter. Some things sometimes people don't think of air, right? Air could be matter. And if you think about something that's not matter, you could think about, the light that is shining into this room is not matter, okay? And of course, you can think of a pure vacuum. Is it ever actually possible to get a pure vacuum? No. And is a vacuum actually something? No. Wow, 2 C's in vacuum? I don't think so. I don't even know. So you've got to think about a thing. And so in this case, vacuum is kind of the absence of a thing. But light would definitely be an example of something that is not matter. All sorts of radioactive energy or radio waves, any of that kind of stuff would all be things that are not matter. But pretty much everything else is. Okay. Other things that are matter, just again, look around the room, anything that you see, many of the stuff that you don't see, for instance, air, is going to be matter. So which of the following are matter? Again, you can hit the pause button if you want to look really quickly and see which one of these are matter or not. And obviously, peanut butter is going to be matter. Motion, no, that's not matter. Water, definitely. Time, no, that's not matter. Light, not matter. Carbon dioxide, boom. Now, I actually just read an article that was kind of interesting, talked about the fact that information is actually starting to be considered matter because they're talking about how by the year 2245, like a quarter of the world's mass is going to be stored information, digital bits. And I'm like, what? But yeah, so they're talking about that being like a 6th state of matter. I don't know if they're going crazy or what, but it's kind of fun to think about that. All right, so let's move on. And we'll talk about something else here. All right, so what is matter? We have 3 things that we want to kind of talk about here with regard to matter. One of them is an atom, and this is the smallest unit of an element that maintains the identity of that element, okay? Chemical identity, again, we're talking about chemicals here. And so if I can break something down to the smallest little bit that still acts like that thing, then we call that an atom, right? Smallest unit of an element that maintains its identity chemically. Now, one of the things that's kind of interesting about the things that we've been studying at the nanoscale, we're actually starting to find out that at the nanoscale, you can have different elements that are behaving slightly different than we would expect them to at the macro scale. So while I give you that definition of an atom, experimental scientific evidence is actually sometimes contradicting that statement. So once we finally got to a point where we could actually look at things at a nano size and actually look at single atoms, we found out, you know what, that little piece of little gold doesn't actually behave like a whole bunch of gold, right? Which if you think about it, kind of makes sense, since gold is going to have a lot of atoms that might have some slightly different properties. But yeah, that's kind of a cool thing to think about. Again, looking at textbook answers versus what we're actually starting to discover. Element. What is an element? Pure substance that can't be broken down into simpler stabler substances or stable substances under ordinary chemical means. It's made up of one type of atom. Okay, so that's an element. Pure substance. That's a big part. You're going to see that word, those 2 words together a bit. Pure substance. Elements and compounds are both pure substances. Okay, but an element can't be broken down. You'll notice that's one of the biggest differences here. Elements can't be broken down, whereas a compound can be broken down. So as you're trying to define the difference between element and compound, notice that one of those things has to do with, 1, the element can't be broken down, and 2, then the compound can be broken down into simpler, stable substances. The element is made up of one type of atom, could be gazillions of them, but the compound is going to be made up of 2 or more different elements. And notice here that I actually use this phrase chemically bonded. It's important to realize that chemically bonded is something that's important for compounds, because if things are not actually attracted to each other, then you're just going to have a mixture. So these things need to be bonded in an attraction. Otherwise, it's not considered a compound. It's just considered a mixture. Okay. All right. So that's what matter. That's what's the matter. What's the matter you? What's the matter me? Sorry. Sometimes the things just come out of me. All right, so what kind of properties of matter do we need to be familiar with? And still waiting for slow PowerPoint slide to advance forward. All right, so we got physical properties and we have chemical properties, right? And so if I think about a physical property, this is something that can be observed or measured without changing something of the substance. Now, what I usually like to put in here is the identity of the substance, okay? So physical property, I can look at it and it can change, but its identity stays the same. Another way you could think about it is its composition or its chemical formula, okay? So for instance, a physical property, if I take sodium chloride, and sodium chloride is table salt, right? Just your typical table salt. And I undergo a physical property, maybe I dissolve it in water. The sodium chloride still has its saltiness, right? It still has that ability to be salt, and it's still going to be salt, even though it now has gone through a physical change. It's now been dissolved, it's been broken up into smaller pieces, basically, and it's kind of attached itself a little bit to water. And so this is a physical property, okay? Something that doesn't change the identity of the substance, but it's a property I can see that has changed. Now, a chemical property is not going to be able to be observed unless the substance actually changes. So for instance, let's say we're making salt. And in the process of making salt, you might have some sodium ions and some chlorine ions that come together, okay? Because you're starting with sodium as a solid and chlorine as a gas. You got a bunch of sodium metal, and you got a bunch of chlorine gas. You put them together in a very electrifying experience, and these things will go from being this, soft metal that kind of melts and turns into a gas, and then this is going to be a gas already, and it's going to get energized. These things are going to come together. Now remember, this is a poisonous gas. This is a metal that can actually touch water and start to explode itself. And all of a sudden you put them together in a chemical reaction and you form a new chemical. That's going to be the sodium chloride, okay? Then it has changed its identity. These things no longer have their original identity. Chlorine and sodium don't have the original identity, new identity. Therefore, a chemical property in this case could be observed. Another good example of that would be burning, right? So if I want to think about, for instance, a piece of paper that burns, right? Maybe that paper is made up of mostly carbons and hydrogens, right? CXHY, maybe it's got some O's in there too, right? So it's going to have some sort of O's in there. That stuff is going to change through the chemical property of flammability. It's going to burn, and it's going to mostly turn into CO2 and H2O, right? So it's a hydrocarbon burning in the presence of oxygen, and that's going to give you something new, and that chemical property is flammability, okay? So you can have some chemical properties, but the only way you can tell if it is a chemical property is if it has actually changed its identity. In this case, these two changed identity to salt, and this one changed its identity into like carbon dioxide and water, okay? So chemical properties versus physical properties. Now, when we talk about these types of properties, we are going to have two terms that we're going to talk about. One of them is extensive property, and the other is intensive property, okay? Now, extensive property, you'll notice there's a phrase here, depends upon the amount of matter, okay? So if I ask you if something is extensive, you're going to want to tell me whether or not the amount of matter changes the value. If I ask you if something's intensive, then you're going to say, oh, well, the amount of matter does not change the identity. Okay, so let's think about some examples here. Mass, for instance, would be a great example of an extensive property, right? Because if I change the amount of matter, am I going to change my mass? Well, yeah, I'm going to have more mass if I have more matter. What kind of things then would fit under extensive property? What is not going to change no matter how much I put into it? A good example that you might be familiar with, for instance, would be like the boiling point, okay? Because I could have a lot of water or a little bit of water, and the boiling point, if I put a thermometer in there, it's still going to just show me, 100 degrees Celsius at sea level, right? And 1 atmosphere of pressure, all that good kind of stuff. Now, other things that you might think of as intensive property, maybe you like the color. If I have a piece of paper and I rip that piece of paper up and it's green when it starts, it's still green after I rip it, right? So it went through some sort of physical change, but the intensive property was color. in that case. Now, color could be, oops, went the wrong way there. Color could be sorry guys, annoying. All right. Color could be something that you would talk about in other forms as well, right? So it could be an intensive property because you rip that paper up and it doesn't change. But what if you had, you know, a glass of water versus a swimming pool of water? Would that same water now suddenly look blue if you had a lot more water and where it didn't, you couldn't see the blue? So you could probably come up with some arguments that might talk about, you know, using different types of properties in different ways. Okay. All right. So your turn. Again, this might be one where you want to hit the pause button, try this yourself. But let's go ahead and boop, hit pause. All right. Now you're back and let's go. All right. So we're looking at sodium. Sodium is a piece of metal, and it is a soft, malleable piece of metal and reacts very violently with water. So let's talk about some of its properties. Let's talk about physical or chemical. If it's shiny gray, physical or chemical? Well, this is a physical property because why? What is physical property again? Remember, you're not going to be, you know, changing it, right? So chemical properties got to go through some sort of change in identity, right? Okay, this key word right here is going to help you know this might be something a little different. Reacts with water to form a gas. Did it change? Did it change into something different? Yes. And so that's going to be a chemical property, right? So it's a reacting is going to be chemical. Okay, your mass, that's going to be a physical property. Your density, physical property. Melts, now a lot of students are going to get this one wrong, right? The melting part is actually, although it might turn into this blob and it's a liquid now, that is still, if you give it a chance to cool down again, it's going to turn into exactly what it was before, maybe just a different shape. So that's still a physical property, right? And then forms white solid heated in the presence of chlorine gas. Okay, do you think that white solid is probably still sodium, or maybe has it gone through some sort of a change? Ooh, chlorine gas. Wow, that sounds like it might be sodium chloride, right? It might be table salt. So yeah, we're looking at something that has gone through a chemical change. So that's a chemical property. The fact that it forms a white solid is a chemical property. Okay. All right. So hopefully you guys are streaming through and getting that and understanding. And let's go on to the next one. Oh, sorry. There's one last little question there. All right. So classify each of these physical properties as intensive or extensive. Okay. So we're not going to do this one, and we're not going to do this one because those are chemical properties, and we don't do intensive and extensive with chemical stuff. We just do them with physical stuff. All right. So intensive versus extensive. And sometimes you're going to hear me use the word intrinsic versus extrinsic as well. So they mean the same things, okay? Shiny gray solid. If I change the amount of matter, is it still going to be shiny? Is it still going to be gray? Yes, it is. And so does it change with the amount of matter? No. And so that's intensive, okay? Mass, 1.5 grams. Does that change with the amount of matter? Yes, it does, right? My mass is going to go up. And so that's going to be extensive. Density. Oh, some of you guys are going to get tricked by this one. But no matter how much of this stuff I add, its density is going to stay the same. And so in this case, this is another intrinsic property, right? So density doesn't change. Why? Because I'm adding more mass, but I'm also adding more volume. So it's a ratio. Remember, density is a ratio, mass per volume. And so it's an intensive property. Melts at 98 degrees Celsius. Again, it's kind of the same thing as boiling point, right? Boiling point is going to stay the same no matter how much of it you have. So melting at 98 degrees Celsius is going to be, right, intensive because it doesn't change the amount with the amount of matter. Okay, now I think we're ready to go on to the next one. And in this next one, we're just, come on. Oh, if I could just get this thing to advance on the slides like I'd like it to, huh? Come on, go back to where you were. What, baby? Hey, there we go. Okay, so now we wanted to review these objectives, see what we've learned so far today, right? Can we define chemistry? Yeah, I think you can, right? You can talk about the fact that it's matter and the changes that it undergoes and the energy changes that might be involved there. Physical and chemical properties. You can now tell me how a chemical property is different than a physical property. Remember that chemical properties need something to be changing, right? You have to have a change in identity for it to be a chemical property. Intensive and extensive. Which one has to do with the amount of matter, right? Extensive. Physical and chemical changes. Remember, a chemical change is going to change the identity, and the physical change does not change the identity, okay? And then the last two here, three common states of matter and the role of energy in physical and chemical changes. We are going to get to that in the next lecture. So thank you so much and have an awesome day.